Welcome back, everyone, to another Forge College Explainer. I am absolutely thrilled to have you here today. Now, in our last lesson, we really got into the weeds on the architectural contrasts of the SVM. We talked about eager versus lazy state sync and how optimistic parallel execution handles conflict detection. Well, today we are taking all that fantastic theoretical architecture and, quite literally, bringing it down to the pavement. Our focus today is validator client diversity and operational implications. I want you to think of today's topic kind of like a mechanics workshop. In an SVM network, the consensus rules, those are your non-negotiable traffic laws. But the validator clients themselves are the wildly different vehicles out there on the road. So today, we're going to look at exactly what happens when all those totally different engines try to drive on the exact same highway. Okay, let's dive right into our blueprint for this explainer. We're going to hit the diversity spectrum, protocol versus behavior, meet the fleet, hitting the road, and we'll wrap up with a diagnostic toolbox. Section 1, the diversity spectrum. Let's unpack what it actually means to have a diverse set of vehicles out there. So, what is validator client diversity? Well, at its core, it just means having multiple, independently developed implementations of a node. The crucial thing to remember here is that all these nodes conform perfectly to the same network protocol and consensus rules. Basically, they all agree on the final ledger. But under the hood, it's a completely different story. Their internal architecture and non-normative behaviors are fundamentally different. They process state differently, they manage memory differently, and they even prioritize transactions differently. They are literally just different engines producing the exact same destination. Moving on to Section 2, protocol versus behavior. This is where we draw the line between the strict rules and the weird mechanics. To really understand this, we have to explicitly draw the line between what is strictly enforced on the network and where these clients are allowed to get, well, wonderfully unique. On one side, we've got protocol compatibility. These are your traffic laws. They are completely non-negotiable. If a node decides it doesn't want to follow the consensus rules or the correct block acceptance messages, boom, it crashes right off the road. But on the other side, we have non-normative behavior, and this is where things get super interesting. This covers stuff like synchronization strategy, RPC surface details, and mempool prioritization. This is the unique engine quirk that dictates exactly how fast your node recovers from a restart, how much data it feeds your indexer, and most importantly, whether or not it's going to trigger your dreaded 3 a.m. pager alarms. All right, Section 3, meet the fleet. Let's pop the hood and see what makes these client archetypes tick. Notice how we can break down our three main vehicle types here. First up, we have the feature-rich, extensible client. I want you to think of this as your massive, dashboard-heavy luxury truck. It's got snapshot tooling, a massive RPC surface for historical queries, and a really nice balanced throughput. Next is the minimal resource light client. This one is your reliable compact EV. It's got fewer optional extensions, a super small and stable RPC, lean checkpointing, and highly predictable latency. And finally, the performance optimized client. This is your highly caffeinated, aggressive parallel sports car. It uses aggressive optimizations, experimental endpoints, and super fast parallel restore to hit incredibly high throughput. But fair warning, that throughput can definitely come with variable latency when things get congested. Section 4, hitting the road. Let's talk about what happens when this fleet meets real-world network chaos. When these completely different clients actually hit the road, the friction points tend to pop up in four main areas. Number one is software upgrades. Upgrading that luxury truck with its complex snapshot tooling requires a completely different playbook than rebuilding the state on your sports car. Number two is tooling integration. Your indexer might absolutely love the rich metadata it gets from the truck, but it might completely break when it tries to talk to the EV. Number three is network load. Just imagine that caffeinated sports car processing and forwarding transactions so fast that it creates this massive mempool churn, which completely stresses out the more conservative EV nodes sitting right next to it. And finally, number 4, incident response. A bug in one client might not even exist in another. That means your emergency rollback procedures, they have to be completely client-specific. Now, if you take nothing else away from this, I want you to burn this quote into your memory. Treat client diversity as an operational feature. It reduces single implementation systemic risk, but increases the complexity of coordinated maintenance. See, the safety of diversity, the fact that a single bug won't take down the entire network, comes with a very real cost. You, as the operator, literally have to learn, maintain, and execute completely different maintenance routines for your entire fleet. Which brings us to Section 5, the diagnostic toolbox, how we actually manage all this fleet chaos. To manage this chaos, we have a secret weapon, the capability probe. Think of this exactly like that little diagnostic computer a mechanic plugs into the dashboard beneath your steering wheel. Right? Before they turn a single wrench, they ask the car, hey, what modules are you actually running? A capability probe is just a diagnostic request sent right when a node boots up to discover its advertised RPC features. And we do this before our monitoring tools make any blind operational assumptions. Let's actually look at how this logic builds into a practical script. Here is the typical flow of a Rust capability probe. First off, you import your standard libraries, so request and SERDI, to handle the HTTP and JSON. Then, you fire off a very lightweight read-only JSON RPC payload. You're basically just knocking on the door asking, hey, what can you do? Next, you extract the optional features list from the node's response. Now, here is the absolutely crucial part, the final step. You adapt your node monitoring based on what comes back. If the node says, hey, I have traced_calls enabled, well, your script turns on richer data ingestion. If it doesn't, your script safely falls back to basics without throwing a massive error and breaking your entire indexer.
Probe early. Adapt monitoring. Fall back to safe defaults. Honestly, this is the golden rule of node bootstrapping. You absolutely must treat capability discovery as a mandatory first step. It is quite literally the only way to survive in a multi-client ecosystem without losing your mind to false alarms.
So, I've got to ask you directly, are your monitoring tools blindly assuming all RPC endpoints behave exactly the same way? Because if they are, I guarantee you the next time a caffeinated sports car client connects to your infrastructure, things are going to break. Seriously, take some time after this explainer to audit your own setup for these hidden cross-client discrepancies. Looking ahead, our next explainer is going to cover the overview of node roles in Solana's ecosystem. And everything we just discussed about engine types and client capabilities, that is the absolute prerequisite for that next step. You really need to know what kind of vehicle you have in your garage before you can decide whether it belongs in a high-speed racing role or a heavy-hauling archival role. I'm going to leave you with this final, provocative thought today. As you build your fleet, will you prioritize the ease of uniformity or the resilience of diversity? It is the ultimate operational trade-off. Thank you so much for hanging out with me for this Forge College Explainer. To master more Web3 topics and continue building your expertise, head over to forge.college right now. I have had a total blast breaking this down for you today, so keep learning, stay curious, and I will see you in the next one.